Let's go to LeetCode 1545, find the case bits in nth binary string. For this question, it gives us an n and a k. Actually, it gives us S1, which is string 0. And then we are going to do nth operation. For every operation, the Si will have the formula to be Si plus 1 and append n1 and then append this kind of operation to Si minus 1. So originally that is 0, right? So for example, when n equals 1, this is 0. N equals 2, we need to have a 0, which is Si minus 1, and append 1, right? And then invert 0. Invert 0, 0 is 1, right? Reverse value, this one is also 1, right? So we append 1. The next round, what we do is first we'll get a Si minus 1. Then we append 1, right? And what we do is do a invert 1, 0, 0, and do a reverse, that is 0, 1, 1, right? So we need to append 0, 0, 0, 1, sorry, 0, 0, 1 to this, right? So ask what's the case element, case bit when we do nth operation. You say that it's guaranteed that k should be smaller than n, smaller equal to n. Actually, it's smaller equal to the nth operation's length, right? Because for every n, we are trying to see what's the length, right? So n equals 1, I say the length is n equals 1, length is 1. N equals 2, the length is 3, right? And n equals 3, that is n will be 2, will be 7, right? And then n equals 4, that is will be 15, right? So it looks like for every n, the length will be 2 power n minus 1, right? We'll see at least 1, 2, 3, 4 follow this kind of formula, right? Now we can also prove, right? So if, for example, n equals I, the length is 2 power I minus 1, right? So for the I plus 1, it is this one plus multiplied by I plus 1, right? So that is 2 I plus 1 minus 2 plus 1, right? So that is 2. So that is 2 I plus 1 minus 1, right? So that proves that the length will be 2 power n minus 1, right? So we can do this kind of question in a recursive way. That is, we know the exit condition is n equals 1, it will return 0. Then for the round n, right, we have the k has 3 kind of situation. One is that it follow in the first half, and the second scenario is in the middle. The third is in the third in the second the later part. So if it's on the first part, the case it will be find just find a bit n minus 1 k, right? Just go back to the first round. If it is on the middle, just return 1. But the hard part is on the later part. How can we do that? And if we know the length, right? So we know for this one, it is n length divided by 2. 7. Because this is a case, not an index k. So that is 7. So this is 4, right? And so should +1. So this is the length divided by 2 +1's item. So for this part, it will be k minus this one, right? And we need to do reverse, right? So for reverse, that is 2 length divided by 2 minus let's write the formula. So that is length divided by 2 divided parentheses k minus length divided by 2 +1, right? And then parentheses. So that is length divided by 2 minus k plus length divided by 2 minus 1, right? So that will be length minus k minus 1, right? So if we do recursively to the previous one, right? So that is find the char n minus 1 and this one, and then also we need to do a flip, right? Flip, that is if the previous one is 1, then this is 0. If this is 0, then that is 1, right? So let's write code for this. We know if n equals 1, right? And k can only be 1, just return 0, right? And we know this length as we proved, right? Just the length 1, it is 2 power 1 minus 1, right? So that will be 1 2 power n minus 1, right? So the things that we know the middle item is length divided by 2 plus 1. So we'll say if k is smaller than length minus 2 divided by 2 plus 1, right? Then we just recursive call to the previous round, just return and k state n minus 1, right? Else if k equals length divided by 2 plus 1, right? We'll just return 1, right? And else, that is on the later part. We'll say char c equals find is it. So we know that is first thing is that we need to find in the k minus 1 in the item, right? So that is length divided by 2. This is on the later part, right? And also we need to do a reverse, that is the length divided by 2 minus this, right? So this one is actually length minus k. This has another parenthesis, right? I have another parenthesis. So that is length minus k minus 1, right? Plus 1, sorry. This is plus 1, right? Because this minus, so that this one will be plus, right? So this is plus 1. So that is find in the previous round n minus one in the length minus k plus one, right? So that means that returns c equals, because we need to flip, right? If c equals one, then we need to return 0, otherwise that is the 1. And so this will be the code. Here, we can also skip the else, right? Okay, we can convert this to Python code. So I say, if n equals 1, right? We just need to return the char 0. And then we're going to have length equals 1 to power n, right? Minus 1. And let's say if k is smaller than length divided by 2 and plus 1, right? And then we return final case. That is n minus 1. Okay, right. And say if k equals L divided by, here we say L if 2 plus 1, then we return 1. Otherwise, we return then say so we can say this: if find a case bit n minus 1, this will be L minus k plus 1 equals 0, right? And else 0, right? Like this.